Hey, welcome back. This is episode 10 of Trading Signals Coding Session. Um, we were we were working on synchronizing the bot, sending the signals with the bot receiving the signals. We wrote the code in the last episode to synchronize it at the simulation loop level. We debug the sending part. We are going to debug the receiving part after some fixes. And then we're going to code the storage of the signals by candle, so everything is perfectly synchronized. Okay, so let's jump into the code where we left it before. Okay, let's stop this. And okay, so we were here at the trading simulation. In order for this to work well, we will need this to check what happens. So trading signals, incoming references, this will hold an array of references, okay? Because if you check the here, you see that outgoing signals might have more than one outgoing references, because with one from one node we can set multiple signals through potentially different social trading bots. The same happens for the incoming signals. So this guy, or this guy to be precise, can have many of these guys. So this is outgoing signals or incoming signals. It might have more than one. What I want to check is I'm going to do it on the other task server. Trading simulation. Probably will do it here because here I have this already in place. Okay, yeah, this is the deal. So this is an array, as you can see here. So the question is now, where is the trading simulation? Here. We wrote this reasoning that the user that would like to have its bot synchronized with a bot providing signals will define at the trading system an incoming signal node and then an incoming signal reference. So what we need to know here is that this is going to be undefined, and that this guy, which is here, the length of this is greater than 0. Okay, this is greater than 0, and that is pretty much enough for us. Or maybe, yeah, we could say that it's somebody have an incoming signal reference, an incoming signals node with at least one incoming signal references. We will use that to assume that the user is trying to get his bot synchronized at the trading simulation level. We don't need to ask for more than that. So, so if this is true, then we will request the signals with doing this. And if there is a signal, we will get the first one. So if there is at least one signal, uh, we need one signal to continue inside the loop, the simulation loop. If there is no signal, it means that this bot, the one following the signal, is running ahead of the one providing the signal. So it's going to break here the loop, and it's going to go to sleep, and when it comes back, it's going to check it again. Okay? And when it finally finds a signal, there's nothing else it should do. It just continue processing, and that's the synchronization mechanism. Okay? So now we are going to try it out. But before that, we are going to write the code to store the signals in by candle. Okay, so we need to find the place where we are storing the signals. How do I get to that place? I cannot remember where it is exactly, but what we can do is to get all signals. We follow this path. See if we can get, where is this function defined? Okay, it's here, incoming signals. So from peer-to-peer network interface, we have another function called, okay, this is the place where the signals are stored. It's called, the place is at the peer-to-peer network interface. Okay, that represents the interface where messages coming from the peer-to-peer network are going through. Okay, so here we have a map, signals by definition ID. In fact, this map, we're going to upgrade it, and we're going to replace the name, because they are signals by definition ID and candle. Okay, or by, I would like even more if it is signals by candle and signal definition ID. Okay, so when a signal is received from the network, what happens is just this piece of code, this tiny. We get a signal, signal message, broadcaster, social rainbow, signal definition ID. Good. But there is going to be a key that is going to be a little bit more complex. So the key for storing the signal is going to be, yes, using this ID. This is going to be replaced by the key, but also is going to get signal source trading system node candle begin. Okay. Signal. I want to To do it wrong, signal source, trading system node candle. Trading system node dot candle. We're going to put this the candle there. It has a begin and an end, so we're going to look for the exact kind of candle. Begin and plus we're going to put some separator here, like a dash, might be enough. Begin and end. So this is going to be the key of this map. Okay. So with that key, we are going to try to get the array that is stored there. If not, we create a new one. We push the signal inside the array and we set with the same key this array. To make this nicer, we're going to put this here. Okay, that's cool. Okay. So when we retrieve the signal, when we retrieve the signal, this guy will need the key, but not this key. It will need this key. But in this case, this is not coming from the message, but it's coming from this parameter. And because this module that we are in, peer-to-peer network interface, have no idea about trading bots, we will add a parameter here called candle. So from this candle is that we're going to get the begin and the end. And this key is the one that we are going to use to get this from here and to set it with an empty array. And that's how we store the signals based on the candle and on the ID of the signal node specifically. I think that is pretty clear. So we will go back to incoming signals, that is the place where we are calling this guy, and we have to send this guy a candle object here, at least with the open and close. Okay, so this is part of the trading incoming trading signals. So this is, yeah, we can assume that we have access here to the candle, but probably not. Get all signals. Who calls these get all signals? Mm. Trading signals. Well, so trading signals, incoming trading, outgoing trading is a module that is part of the trading signals project. Okay, so it's a little bit far from the algorithmic trading project that is where all this stuff is going on. So it kind of makes sense that this guy receives a candle via parameter and not access the trading engine itself. But at the same time, in the outgoing case, we are accessing the trading engine anyways. So I wouldn't do it in one and not in the other. So okay, I can also make it to get the candle and modify every function call to send the candle. But because for the candles of the trading engine we have to use this value property, I will have to either make a conversion there or use it here. So in the end, it's like this module will have certain knowledge of the trading engine. But I don't see it that bad. Probably it shouldn't, but who knows? So what we will do is that we are going to create a candle object then inside the incoming. Extracting the information from the trading engine, and this is the candle that we are going to send here when we want to retrieve the signals per candle. All right, cool. So everything looks like in place except for one thing, that if you remember when we were at the trading simulation, there was this doubt about when is the candle at the trading engine being updated. Okay, when? Because the loop starts here, it updates the index of the candle, but not the candle itself. So when it updates the open and the close, that is what we are using as the key. So we have to figure that out. And to figure that out, we should get the trading episode node or trading engine module. Trading engine module. What do we have here? Add the trading engine, set current candle. Okay, here is the place where this is updated. Where are we executing this from? Learning now, trading engine. This is the function declaration. This is portfolio, learning, trading simulation here. Okay, so this is after our check. That means that our check, we have to move it below here. We should move it below. Okay. What is it doing here? Okay. We're going to clarify a little bit this stuff. By the way, this is the right way to log something. when it is an information. And I was doing a few episodes back something not very good that was logging directly to console. The right way to log this is this one. And you put this in here. Run simulation loop, or not loop because it's not inside the loop, but this. And we put the time. Okay, and we can delete this guy. So it's going to be recorded inside the log files. We're not going to see it at console per se, but if you are debugging and you want to appear in console, just change this for error or warning, and it will most likely be sent to console too. Okay, so that's the pro tip of the day. Okay, so let's come back where we were. We were saying that this is logging about the current candle, and here is doing what we didn't know where it was, that is setting the current candle at the trading engine. Okay, well, it seems that my commentary was not needed after all. Okay, so once this is updated at the trading engine level, then we are going to do our magic, that is seeing if we have to receive a signal or broadcast it. Okay, so we were doing it ahead of time. So this is how this goes. Yeah. Signal synchronize or signals code follows. Okay, so this is the signal stuff. Then it continues with the heartbeat and whatever. So incoming signals code follows. Outgoing signals code. We don't need to put this. Okay. It seems that we have it all because we have the signal stored by candle. We have already checked that the candle is going into the signal message. Okay, we already debugged that, so we don't need to do that again. What we are going to debug is the incoming signals side. So we are just going to run this guy here, and we are going to put, or we are going to run this one as the incoming signals. So I want to see that this is stored properly. I want to see that this is retrieved properly. And at the trading simulation level, I want to see what happens here. Okay, so what we are going to do then is run the first task. We are going to run it directly at Node.js. Where is our console? Our console is here. Okay, so let's see if everything gets reset well. Not really. So if you are looking into contributing into SuperAlgos, there are some places here where you might want to fix some stuff like this. Okay, so this is runnable. This is runnable. I'm going to run this. And I'm going to run task server 1. My god, how I get this upwards here. Okay, task server 1 is running. That means that I can hit debug here. And it connected to the network node. Okay, so now from this guy, I'm going to run the bot by running the session. And now we got a signal received here. Signal message. Okay, so oops, what is wrong? Signal source trading system. I forgot the source. Can you believe that? Source. We will go again. Why is this not running? Why stop running? Ah, it doesn't like that the other guy stopped. Okay. We run it again. We run this again. We connect the UI hitting debug here with Visual Studio Code. Okay. Then we run the bot and it will stop here. Okay. So we will have this key now. That is, it includes the begin end of the candle plus the ID of the signal definition node. So this will do its job and it's going to save it here. And in fact, if you look at this entries, the key is perfect. Okay, so this is working. Hmm. It's working, but I don't know what happened. Ah, okay, yes, I know. We ran the bot, this guy sending the signals, and now we need to run this bot. What was running was the task receiving the signal, even if the bot is sleeping, which is perfect. Okay, so we run the bot, and we expect it to stop here. Here it is. So if this is undefined and this is undefined and this is greater than 0, which is, oh, it was our case. It's not undefined. My God, I cannot believe it. Okay, we go again. This one crash. In fact, it didn't crash. Okay, let's go and run it. Then we can run this task. And then we can debug here. Then we run this bot, start producing signals, and then we run this bot. Then we're going to test this one running first before this one. Okay. So this should arrive here, and now it should enter here. Okay. So it's going to get all signals. We are going to go inside. Oops, there is a problem here. It didn't work. Trading engine is not defined. So it was defined at the outgoing, but not at the incoming. That's great. Okay, no problem. We'll do exactly the same stuff. We put it here. We put it here. And now that I'm thinking about, we are never finalizing this stuff. These new objects, the new modules that I added, are not being finalized anywhere. You have to be careful with that. because that's how memory leaks happen. Remember, we came here and added these guys. So where is this finalize? Or this one? Or this one? Or this one? Trading system, trading records, trading modules. They're all finalized here. Okay. I will take these guys with me. No. Okay. So we didn't have this set up. Okay. So we go again. We stop. No need to stop this one. But we can run this one. The task, it doesn't matter if I run it first one or the other. They are independent processes. So I run this one. Then I can debug this one. What is going on here? Did I run this one? Looks like not. Run. Okay. This is running. Run the bot to send the signals. And we run the bot to receive the signal. And wait. Here we are. Okay. Okay. Okay, we will have a candle. So we send the candle makes a key, and the key gets an array with one element that is the signal from the trading system, okay, which also have a candle, but we don't need it right here. So we return here we return and here Okay, signals. We get the signal, and because the signal is not undefined, this means that we can continue. Okay, so we are going to broadcast, but here there is no broadcast, and this is going to continue. Okay, it looks like it worked, all everything. So very good. Now we are going to make the test. What happens if this bot runs first and the signal is not there? Well, what is going to happen? You guess it's going to go out of the loop, and it's going to start only when the signal is there. Okay, so we're just going to test it. We stop here. We stop this one, and yeah, we can start this one. We can start the one emitting the signal, but we are not going to run the bot just yet. First, we are going to connect this with debug. Okay. And now we are going to run this first. So it will stop here. You will recognize that it needs to get synchronized, but it will get no signal. So it will be undefined. That means that it will go to the end of the loop. Okay? And it's going to continue executing, going to briefly go to sleep, come back to life. Or not really. It seems that it doesn't come back to life. It considers the session as to stop the session, because it is requiring to run the session again. Okay, so we got a problem there to solve, pending to solve. I would like to see what happens with the other signals, the ones from I would like to make a test just to let it run, because chances are that the bot consuming the signal is going to consume all the signals well now. But first I'm going to run the one producing the signals, and I'm not going to do it on the Visual Studio Code. I will do it both on but Node.js. So let's stop this guy, and let's stop this guy. Another thing I will do is to come here and delete the data of the trading bots already recorded, and my data storage. I will delete all this. and I just going to run both of these guys. So whatever they produce, we are going to see it at the chart. So this one goes first. Both tasks need to be alive. That's one of the things to consider here. Okay, so both tasks are running or about to be running. Okay, they're both running. And now we are going to run the first bot, let it go ahead a little bit so the signals are there, because we have this issue that it gets synchronized but it kills the session. We'll let it run for a while because it's a little bit heavy what it's doing, especially signing the message. We discovered a few episodes before that signing messages is a expensive task. Well, probably I could let this guy go, or maybe not. Let's wait for the other. So recapping a little bit, we almost have this working. Um, I guess that the work ahead is related to make ourselves sure that everything is working well in all the edge cases. And yeah, and then looking at the charts to see what we can see on the, especially on the bot that is following the signals, and seeing I want to see what is going on with the visual debugging in that case. So that's what is coming soon. Okay, this is almost finishing. It's almost finishing. So we're going to launch the other guy. Let's see if we have any strange stuff at our console. No, this is running beautifully. So let's run the other guy that has all of the signals already at the task memory. So let's see what it does. Whoa, it's really going fast, this one. Hopefully it's doing its job. That's it, babe. Well, that was good. Errors here, no errors. So we're going to stop it. We're going to stop this guy and we are going to see at the charts. And with a little bit of luck, we might see things working. So this is the guy, lightning strike sending signals, lightning strike receiving signals. So obviously the guy sending the signals ran perfectly well through the whole episode. No problem there. The other guy, Control Shift A to adjust the the aspect ratio. So it doesn't seem to have worked perfectly well. So I guess that the next episode will be about finding out what is the problem that this didn't work perfectly well. So it triggered the strategy. Let me turn on the layers. So limit orders, I don't see any. Limit by orders, I don't see any. Manage stages. Okay. Okay. So essentially there were no crashes. The bot ran well. It finished its simulation with the constraint of being synchronized. Uh, we will need to debug more in detail what's going on with the individual signals. Maybe we forgot something there. We are storing this by candle now, so I don't know. Um, well, this episode number 10 of coding sessions, trading signals. As you can see, in the first 10 episodes, we advanced quite a lot. We almost have it working. I believe that in a few more episodes, we will see this working. And we will take it to the level to see how it looks like here. And also, I want to see the panels, if there is, if we can give any hint of the condition of somewhere that the body is acting by a signal and not by its own stuff. Obviously, it's not going to just appear, but maybe we can do something, or maybe it's interesting, or maybe not. Then I will check the visual debugging that everything is well connected and working, and I would say that we almost have it. We almost have it at this point. We can see the light at the end of the tunnel. So this is all for now. Hope to see you at the next episode. Thank you for watching this one, and see you next time. Bye.